Hi, in this video, we will talk about hash table. This is a class in Java. Hash table is a class in Java. We'll talk about this hash table. So under this map, so it will come, hash table comes under this map. You see here, hash table. So then we'll talk about this hash table. So what is hash table? The underlying data structure for hash table is hash table. Okay. So hash table data structure is hash table only. So duplicate keys are not allowed. Duplicate values are allowed. The same thing as it is comes under map. So insertion order is not preserved and it is based on hash code of the keys. So hash code values of the keys, according to that, it will insert into the hash table, right? It is not preserved. It depends upon the hash code of the keys. So heterogeneous objects are allowed for both keys and values. So heterogeneous objects are allowed for both keys and values. Null insertion is not possible for both keys and values. Here you cannot insert null value for both key and value. So we'll get null pointer exception if you try to insert null. Okay, if you try to insert null as a key or value, you will get a null pointer exception. Okay, so what are the constructors available in hash table? So hash table is equals to new hash table, the basic constructor. So it will create an empty hash table object with the default initial capacity of 11 and the default fill ratio is 0.75. So the moment it creates, it fills 0.75%. So it will create another hash table. Okay. So constructors, another constructor is hash table is equal to new hash table. You can give your own initial capacity. So how many value means the entries you can put into the hash table. So it will create an empty hash table object with specified initial capacity. So it is an efficient way if you know the capacity. So you have prior information. Okay. So another constructor is hash table is equal to new hash table, int initial capacity and float fill ratio. So the default fill ratio is 0.75, but that also you can give your own value. Okay. So it will create an empty hash table object with specified initial capacity and default fill ratio is specified fill ratio. You can give 0.6, 0.9, something like that. When it reaches that percentage, then it will create new hash table. Okay. And the last one is hash table is equals to new hash table of map. Okay. So it will create an equivalent hash table object for the specified map object. So what is the use of this? This constructor will be helpful for interconversion between map objects. Okay, these are all 4 constructors available in hash table. So how the internal logic will be, how the hash code means, how with the help of it depends upon hash code we mentioned, right? The keys. So how it will be inserted internally, we'll take one example and see here. Okay, so here I have one hash table. So let me annotate this. So here I have a hash table. Hash table is called new hash table. This is basic constructor. So for this, what is the that the default value of this 11 with 0.75%, that is fine. But you can insert only 11 values. Okay. So ht put 5 A, 1 B, 7 C, 15 D, 23 E, 16 F. So before going to this, first we'll write the, let me clear this. First we'll write the program and we observe the, output, and we'll go back to the diagram and talk about that. So hash table, T is small. In the hash table, T is small, HT is equals to new hash table, and I'll try to put some values. Hash table will put 5 comma A. Okay, let me take this. Okay, So let me put this one 5, 1, B, and then C, a 7, and D, 15. Instead of 5, I'll take 23, E, F, this is 16. Okay. So I have taken these values and I will try to print this one. System dot out dot println HT. Okay, right. So here, how it will be stored? Hash code of this key, right? If it is integer values, you don't know. Okay, we'll do one thing. For integers, we don't have any problem. Okay, first we'll take as it is. I'll take again another hash table. Okay, here I'll put the capacity as 30. This is 11 and this is 30, and I'll make this HT1, and let me change all these things. Same values, and you observe the output. Okay, so I have taken with default value 11, and I have taken another constructor. Initial capacity is 30, and I'm inserting the same values. Then you see the difference between these two. So let me execute this. Java hashtable demo.java. You see that different outputs were these different constructors. Strange, right? So there also I have 6 elements. Here also I have only 6 elements, 1, 2, 3, 4, 5, 6. Here I have capacity more than this 11. Here also I have the capacity more than the 6 elements. Even though with the 11, with the 30, I have different output. You see? And I don't know how the output is coming. Right? So that is the different according to this hash code. Because of this hash code, the output is different. Right? So if it is integer, we don't bother about the hash code. By default, it will take as this, what do you say, ascending order. Okay, but I'll implement my own logic. Okay, I'll create another class. So if it is string or something like that, we don't know. So because of the, to understand that class hash code value, I'm just giving one name hash code value. So I'll take int I. I'll create a constructor hash code value. Here also I'll pass int I. Inside this, I'll assign that value to this one. This dot I is equals to I. Okay. And public int, I will use hash code method. This will return I value. Whatever I value, I'll give the same value. Here I'll public string to string, I will override. Why I'll override, I'll tell you. Return string dot value of I. I'll convert that integer value to string and I'll return that. Okay. So what I'll do here, I'll take one more hash code, hash table. Okay. So I don't know the hash code value, how it will be internally. So I'm giving my own hash code value. So here, instead of 5, I can put any object, right? New hash code value object. This constructor I'll take. I have a parameter as a constructor, right? Whatever I'll pass here, that will I assign to this I value, and I'll return the same value as hash code. Right? Fine. So let me change everything. So I don't know internal hash code value. So here I'm giving the hash code value explicitly. For that, I have implemented my own logic. If it is all numbers, so by default it is taking ascending order. But if it is something string, all these things, we don't know. So because of that, forcefully I am implementing some logic. Whatever I'll give here, consider that as a hash code. Whatever value I pass, consider that as a hash code value. Okay. Now I need to print this I'll make it ht2. So toString method I'm converting and giving it in the form of string. Okay. So why I have written this logic? So I'm returning I, but this value is, how can I get here? How can I print that one? With the help of toString. But it will return string value, but I have integer value. So I'm converting this integer to toString and I'm taking here. So because of that, I overridden the toString method. Okay. So here also, if it is 30, you'll get the same output. Okay. You'll get the same output. So this hash code value I implemented internally. So if it is integer value, so you don't see any differences. But if it is something else, then it will convert that hash code value to whatever value I have given. So if I try to print this one, the last one also will get the same thing. It's 23. But if you remove this 30, the first value, third value will be same. You see, first value, third value, right? So if it is integer values, we don't see any help of writing this hash code value class and returning this hash code value and converting to toString, all these things. No need, no help with the help of, means what you say, like it is of no use. Okay, it is of no use. But if it is something else, if you take key, then for that key I don't know what could be the hash value. I am forcefully giving some values. Okay, so at present comment this, we don't need, I'm just explaining that. So here what we need to understand, I have taken the more capacity than what I'm inserting. I'm inserting 6 values. I have 11 here, I have 30 here, 6 values, same values. But here different output, here different output. Why like this? So that we will understand. We'll go back to the PPT. So here we'll try to understand what internally it is happening. Right. So when you create hash table, so hash table will create with this, you see 0 to, sorry, 0, 1, 2, I missed 3. Okay. But actually it is 3, 4, 5. So give me 1 second. I'll change that. So I corrected this. So it will be 11, right? From 0 to 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So initially it is 11. So I have a hash table here. Hash table ht is equals to new hash table. Internally it is 11. So I have 11 buckets. So technically we'll call it as buckets. So 11 buckets created. So I'm putting 5A, 1B, 7C, 15D, 23E, 16F. Right. So now I want to place this here. So put 5. So hash code 5. So I am putting in the 5th hash code. 5 is equals to A. Okay. This value I am placing here. Okay. Now 1 is equals to B. In the 1 place, 1 is equals to B. Okay. In the 7th place, 7 is equals to C. Right. So these are hash codes. So according to that, I am storing there. Right. So now till here it is fine. Now it became 15. So there is no 15. I have only till 10 only. So what is the logic? Key percentile 10. The logic will be like this. If it is here also, what you'll say 5 percentile 11. If you take this one, 5 percentile 11. 5 percentile means 11, 0 is a 0, right? 5. So you'll take 5 only. Percentile means this one, right? Reminder. So if you take 1, 11, 11 0 is a 1, right? So because of that, I am not doing percentile directly. If it is less than this value, 11 value, right? But when it comes to the 15, there is no 15. Then if you apply the same logic, 15 percentile 10, 15, 11, 11 1 ja 11, then it is 4, right? Then it will go to the fourth element, the fourth hash code. You see that in the 4, 15 is equals to D. Okay. And the same way 23, right? 23, 11, 11 2 ja 22. Remainder is 1. In the 1th place, 23. So you can put more than 1. 1 equals to B, comma, and then 23 is equals to E in the same hash code, right? Coming to the 16, right? 11 1 ja 11, then it is 4. In the 4th place, sorry, yeah, it is 5, right? 6 minus 1, 5. In the 5th place, 16 is equals to F, right? This is how it will place the values. So it is placed fine according to this logic. It placed here. Now how it is printing here, there also one rule is there. What is that? So from top to bottom, okay, top to bottom it is coming. So 7 equals to C first, okay, then coming here we have 2 here, then again confusion. So this order, if you say left to right, right, this is left for me, so left to right, something like that, okay, right to left or left to right. So first it has to come this direction, okay. So in that direction, 16 is equals to F first, 5 is equals to A next, then again top to bottom, again 15 is equals to D. Now when you come here in this hash code, here you have 2, again this direction. First 23 is equals to E, 23 is equals to E, and then 1 is equals to B, right? That is how it printed the values, right? So give me 1 second. Yeah, if you go to this here, you see that 7 equal to C, 16 is equal to F, 5 is equal to A, 15 is equal to D, 23 is equal to E, 1 equals to B, right? So now, but when it is 30, okay, when it is 30, then why it is different output, right? So let me clear this. So we'll go to the next slide. Right here, 30. Right. 30, same logic I have here. What I took only till 23. The reason is I cannot place everything 30 elements, 30 what you say rows here, boxes here. So whatever from 0 to 23 I took, and the above you will have 24 to till 30. Okay, but I want only till 23 I took, and in the middle also I skipped something. Whatever I want I took. Okay, so now if it is 5, it is less than 30, so directly it will go to the 5th position only. 5 is equals to A. If it is less than 30, directly it will go to the 1 equals to B. Again 7, it will directly go to the 7, directly go to the 15, directly go to the 23, directly go to the 23. If you have here 32 comma G, something like that, then where it will go, 32 of 31 ja 3, then 2, then it will go to second place. When you see if it is 2, 32 is equals to G, something like that it will come. But these all keys are less than this. So we can directly place those. We have 30 buckets here already. So because of this behavior, we see different output. Now you see from the top to bottom, there is no left to right, only top to bottom. So 23 is equals to E, 16 is equal to F, 15 is equals to D, 7 is equal to C, 5 is equals to A, 1 equals to B. Right? Internally, the logic is something like this. Because of that, the output is different for different capacity. Okay? Right? We have seen the same thing here, different outputs for different capacity. Right? That is how hash table works internally. Okay? So what could be the possible interview questions from here? What is hash table in Java? What are the different constructors available in hash table? Okay? So that's all in this video. Thank you.